The goal for this video is to use the squeeze theorem to evaluate the limit of this multivariable function. But what I'm going to do first is, I will actually show you guys a wrong approach. This one step is going to be wrong. I want you guys to think about it and then tell me which step is wrong. And then afterward, I'll show you guys the correct way to do it. So here we go. We have xy approaching the origin, so keep that in mind. And I'm just going to start with putting the absolute value around the function. And because of the absolute value, this right here is always non-negative. I will tell you this is for sure correct, so this is not one of the considerations, okay? All right, next I'm going to do some algebra. The absolute value of a quotient is a quotient of the absolute value. This is equal to, if I put the absolute value around here, x squared plus y squared is always non-negative, so there's no need. I will just have x squared plus y squared. For the top, I will just say the absolute value of a product is the product of the absolute value. So I will put absolute value of x times absolute value of sine of xy. So this is my step 1. Next, I'm going to simplify the denominator by taking away some part of it, and then the key right here is to use inequality. I don't like the y squared. I'm just going to take it away. So I will just have x squared on the bottom. On the top, I will keep it. Now, it looks like y squared, of course, is never negative. I took this away, so the denominator here is bigger than that. So the whole fraction should be less than or equal to this. So this is my step number 2. Okay. Next, I don't like x squared, so why don't we take it away too? So we have absolute value of x times absolute value of sine of xy. Again, I take away x squared, so this thing must be less than or equal to that, right? Now that's step number 3. It looks like it's about time for us to evaluate the limit. xy is approaching 0 and 0. So here, this right here will be approaching absolute value. X is approaching 0. Here we have sine of x is approaching 0, likewise y. So that's what we have. So that is step number 4. Now, it looks like this is okay, because originally you have a 0 over 0 indeterminate form, but this is just 0 times 0. So I will say this is just equal to 0, and that is my final step. And that being said, the conclusion is the limit right here is equal to 0, and then we are done. But of course, you know something's wrong. I told you guys that earlier already. Now think about which step is incorrect, and then we'll go from there. Ready? All right, I will tell you. Step number 3, going from here to here, is incorrect. And now you might be wondering why though, because earlier we took y squared away, and then that was less than or equal to, yeah? And then now we took x squared away, and still less than or equal to, why isn't that the case? Well, the key is, this is x squared, but what's the denominator here? The denominator here is technically 1. You are comparing x squared versus 1. Yeah, x squared versus 1. For example, if you have, let's say 4 over x squared versus 4 over 1, which is bigger? Well, the answer is we don't know, because we don't know what x is. X is approaching 0. In fact, imagine if x is 0.1, then in that case, 4 divided by 0.1 squared, in fact, this is bigger than that, right? So we cannot say this is less than or equal to that. Okay, so let me just say if, yeah? So this step is wrong, but this step is okay, because when we have plus y squared, this denominator is for sure bigger than that denominator. Yeah, but x squared is not necessarily bigger than 1. That's the point. All right, so this is bad. Now this is the correct way to do it. Right? This is the correct way. Correct way. So still, I'm going to put this in an absolute value first. So absolute value of x times sine of xy over x squared plus y squared. And that said, we can say that is always non-negative. Then what I'm going to do next is, instead of do the algebra like this, and notice that it was okay to take away y squared and stay like this, and you might be thinking, can we cancel the absolute value of x with x squared somehow? Well, if you do it carefully, you will still end up with an x on the bottom. When x is approaching 0, it's a little bit trickier, so don't do it like this, but check this out. Notice we have sine of xy. I am going to break this down inside. I will put x over x squared plus y squared together like this, and then we still have the sine of xy like this. But I'm going to divide this by xy, the same input as the inside of the sine function. And the moment you divide it by xy, you will have to multiply the top by xy like this. And that's just some algebra. And the reason that we do this is because now we can say the absolute value of a product is a product of the absolute value. So I can put the absolute value right here. And this is just x squared y over the same thing like this. And then absolute value of this, sine of xy over xy. Right here, we can simplify this expression by doing some inequality work. I am going to take away, which one? Do not take away x squared, because if you do so, y and y squared, only one of the y's can cancel. We will still have a y on the bottom. Take away y squared, it's better, because this and that matches exactly, so we can cancel them out. So take away y squared, and the result for that is absolute value of x squared y over just x squared. This denominator is bigger than or equal to this, so we will have the whole thing being smaller than, so we have this, yeah? And then this right here stays, so absolute value of sine of xy over xy. Now check this out, this and that cancel very nicely, isn't it? Yeah. So of course, this is equal to absolute value of y times absolute value of sine of xy over xy. Now, remember xy is approaching 0, 0, and this is what? Look at xy as a new variable. So we can say theta equal to xy, and because x and y are approaching 0, so that means theta is approaching 0. And we know the famous limit as limit theta going to 0 of sine theta over theta, this is equal to 1. So all in all, this right here is approaching absolute value of 0 times 1, which is just equal to 0. And we see that the absolute value of this function is in between of 0 and 0 as x will approaching 0. So that implies this limit must be equal to 0. And I think this right here is a good enough work to show, to conclude that that limit does give you 0. So make sure when you work on inequalities, each and every step is reasonable. Now, here's a small homework question for you guys. Try to use polar to do this. Yeah, it's possible, and try it.